Greetings to all. Welcome aboard my Volkswagen Beetle, which once again has problems. Now, I should say, you've seen a little bit of this car in previous videos. This is a 99, so it's the second year that they made them. This particular car was built in October of 1998, so as much as I really hate to acknowledge it, it is the better part of 15 years old. Let's say I remember being driven around in this car by my grandmother in a booster seat back there. So yeah, I'm almost 21 years old. So yeah, this car has existed for well more than half of my life. In any event, we have issues. Last week, had a very weird situation where I was left completely stuck in the middle of the road with the car completely dead because the positive lead off of the battery, the cable snapped. Just completely snapped, broke in half. It wasn't the connector onto the battery terminal, it was the cable itself just broke. And now the repercussions are, after a $500 repair bill, because of course they can only replace the entire fuse box on top of the battery, not just the cable. For those of you who don't know these cars very well, there are two fuse boxes. There's one inside the dashboard in here, behind a panel, which is actually being covered by the door right now. But there's a fuse box in the dash, and then there's a fuse box on top of the battery in the engine bay. So over in that area right there. As a repercussion, it appears to me that the throttle control module is either semi-functional or completely non-functional. With data to back that up, I'll show you in a second. At the moment, I'm running these DTCs. That's not normal. There are stored codes, I'm absolutely sure of it. There we go. Main catalyst efficiency below threshold on bank 1. I know what that problem is. That is, I have a bad catalytic converter. Over the years, this car had multiple issues with ETC sensors and air metering sensors, all of which messed up the fuel mixture tremendously. So for many years, we were running with sporadic misfires and whatnot. So whenever the engine was running and the car was cold, it was just dumping raw fuel into the exhaust, which means when everything heats up, it just explodes inside the catalytic converter. So over the years, it took its toll. The cat is now damaged, and I'm going to have to get that fixed. The number 2 code that we're running is a misfire on cylinder 1. I'm not exactly sure what's causing this. This only started after the problem that I had last week with the battery cable. So this is a sporadic misfire. This isn't happening all the time. A couple days ago, I was driving the car and I just noticed a tremendous loss of power. And I noticed the engine wasn't going to rev really too much past 4,000 RPM. So I noted that and I plugged in a scanner and I saw the 301 code. But I'm not exactly sure what the cause is. Check the wires, things like that. And the engine's actually running pretty evenly last time I drove it. Appending, I'm running an oxygen sensor code. In addition to the 301, I've got, 134, yeah. O2 sensor circuit, no activity detected, bank 1, sensor 1. I'm 99% sure this is associated with the cat, because this is, I think that's the oxygen sensor on the post-cat oxygen sensor. In any event, running the live data now. I'm going to start up the engine. The car has not been started yet today, so I'm showing an external outside temperature, ambient temperature, of about 43 degrees, as you might be able to see there. So I'm going to show you what I'm talking about when I talk about the throttle control module being out. RPM, spark advance, intake air temp. Yeah, it might be necessary so you guys get a better idea of the running conditions. Throttle position sensor, that's going to be the critical. The TP percentage is going to be critical. That's sort of the secondary air system, which really comes on, but can't really say. And that's the OBD online. I guess the voltage on the oxygen sensor we'll take a look at as well. So the coolant temperature right now, ETC, item number 1 up there, is 37 degrees, all these obviously in Fahrenheit. All the numbers here are the empirical US measurements, which really doesn't apply in this case. The throttle position, you'll notice, is at 3.5. This runs normally between a range of 3.5 and 77.3, so this is not on the throttle. And now full throttle at 77.3. So you'll see that sensor, that's obviously coming through the throttle position sensor, that's working normally. However, the throttle control module on these cars, some of these cars had fly-by-wire throttles, and some of them, like this one, have a traditional throttle cable. In any case, the throttle control module works to manipulate the throttle without the driver's input in a number of running conditions, such as cold idle and whatnot, to make sure the revs stay even. And also, this device gives the ECM, the engine control module, one of the onboard computers. There are 2 onboard computers on this car, one for the engine, one for the gearbox. But it gives the ECM data with which to adjust the spark timing and the fuel injection density. And you'll see in a moment why I believe that that's not working. So we'll go to start the engine now. And you'll notice I actually have to be on the throttle a little bit manually to make sure that this thing starts. So about 4.5, around 4.7 is the nominal that I want this to be at. So once I get that number, there we go, we'll start the engine. Alright, so the engine's running. The coolant temperature is a little bit too low for the secondary air system to kick in. It usually comes in when the temperature is up to about 45 degrees or so on cold start. But typically anything below 30, the air pump doesn't come on for that system. But you'll notice I'm actually, see the throttle position at 7.8. That's because I'm manually on the throttle. When I come off the throttle, watch what happens to the revs. Yeah, they drop down to 630 in this case. The normal idle speed for this engine on cold start is about 1,000 RPM without any sort of driver involvement. Right now, as you can see, 3.5 is analogous to 0% on the throttle pedal. And it's running at 580, 595, 600. Under normal running conditions, with everything healthy, usually idles about here on cold starts. So about 1,000 RPM or so. And the reason that I believe this is the throttle control module is because that number, the TP percentage, the throttle position, normally by itself in a cold start condition, or really any sort of running condition, will change by itself. It normally goes between a range, obviously starting from that 0% 3.5 figure, usually around 6, 7 by itself, just with the engine starting cold and idling. So obviously we get a low idle, like right now. I go back to 3.5, I'm off the throttle. So when I come back onto the throttle, I raise the revs back into their normal cold range, and you can see the throttle position sensor responding to that. The byproduct of this situation is that when a car is just started, I really can't move it because there's a strong chance that the engine will stall. So I really do have to wait until the coolant temperature reaches about 135 degrees or so, because I'm not sure if you can see it so well on this video, but the blue light just underneath the brake light, that's for the parking brake, that is the coolant temperature. That's just telling me that the coolant temperature is a little low, and they do tell you, even in the owner's manual for this thing, they tell you avoid heavy throttle usage, avoid high speeds until that light turns off. And correlating it with my data here, that turns off at about 135 degrees. At that point, the engine does run better, and it will hold a nominal idle without any sort of driver involvement. See, right now the temperature is at 86. I'm off the throttle again, and we're still idling low, about 700. That's a low idle for any running condition still. Normally when this thing's up to temperature, like at ETC 160, 170, this thing will idle under normal conditions at about 850 RPM. Actually, anywhere between 790 and 900 is a normal range for that. But as you can see, we're still well below that range. But again, there is no misfire. The engine's running smoothly. It's running slowly, but it's running smoothly, so there's no miss. And typically when the temperature reaches about 100 degrees, I'll start to pulse the throttle just to get the coolant circulating a little quicker and facilitate the warm-up. The other symptom that I want to talk about is related to the throttle control module. The cruise control doesn't work. It doesn't work under any sort of running condition. Normally on this car, the cruise control becomes active at speeds above 22 miles an hour, and we'd activate it on the left stalk by flipping the switch on and then hitting the set button on the side, and that would activate the cruise control. And obviously then this would become accelerate. We'd hold this button down for coast and for speed set, and we'd deactivate the system again by turning it off. System doesn't work under any sort of running condition, and because this car, even though it has a throttle cable, obviously there's a motorized device associated with the throttle control module that manipulates the throttle under the cruise control running condition, and cruise control system is completely inoperable, which again leads me to believe that it's the throttle control module. I'm blipping the revs on my own, so that's not the computer doing anything weird there. The dashboard, obviously we got the mill on, associated with the two DTCs, parking brake light obviously, and the cold light still on. The real travesty with this car is, no, the odometer has not gone past 1 million and reset to 0. That's the actual mileage since new, back in October 1998, 48,688 miles. That's all this car's ever done in the better part of 15 years it's been on this earth with us. So for this thing to be having all kinds of problems is just a travesty, in my opinion. It hasn't lived half of its life in terms of mileage. I mean, it was bought new, one owner. It was garage kept for about 12 years. And in those 12 years, it went about 22,000 miles. Not going to say that that might not be the genesis of all of these issues. That it literally, it averaged, oh my God, less than 5,000 miles a year. I'm not very good at math, but let's just say we used to change the oil in it simply because we forgot the last time we changed the oil. It wasn't because of mileage. So the temperature's coming up now. This is just a normal warm-up procedure, to be perfectly honest with you. I basically have to do this every time I get into the car when the coolant temperature is below 100 degrees. Now the car will drive right now, but again, like I said, there's a good chance it's going to stall until that temperature reaches about 135 degrees. Let's see, I'll come off the throttle. Where does the engine idle? Now that's a normal idle condition. If I wanted to, I'd drive the car right now and I'd have no problems. But again, look at the temperature. It's over 130 degrees, so it has to get that hot before it really will start to run normally. I'm not sure how much you can hear the engine, but everything's running normally. It's smooth. There's no misfire that I can detect just with my feel and with hearing it, but even now the idle is still a little low. But let's see, you'll see the cold light turn off in a moment. Coolant temperature 135 indicated, and the light's off. So yes, you can see the correlation. So at this point the car is, at least the engine is warmed up and ready to go. There's no temperature in the gearbox obviously because I haven't gone anywhere, the car hasn't moved. But yeah, this is now the warmed up idle conditions that you could see for everything. I'll show you the complete data set now. So the DTC count at 2, fuel system online, calculated load percentage, which is nominal and minuscule, considering we're not moving. Coolant temperature, short-term fuel trim, long-term fuel trim, RPM, vehicle speed at 0, spark advance, intake air temperature, the MAF flow in pounds per minute, throttle position, secondary air system status, it's off, and the oxygen sensor voltages now. This is bank 1 sensor 1. This is the short-term fuel trim indicated by on bank 1 sensor 1. And this is O2 sensor, bank 1 sensor 2. So, and obviously the OBD system is online. I'm interpreting sensor 1, and I'm probably wrong on this. I believe sensor 1 to be the pre-cat oxygen sensor, and I'm interpreting sensor 2 to be the post-cat oxygen sensor. Those voltages on sensor 1, it's fluctuating wildly. Sometimes it goes down to 0, sometimes it goes up past 1 volt. However, sensor 2 is typically pretty stable at the 0.475, so around half a volt. That fluctuates a little bit, but really nowhere out of that range. But sensor 1 is all over the map, as you can see. So I'm not entirely sure if that sensor is okay. Problem is, I don't have a lift or any sort of equipment like that, so I've been under here. I've tried to take the oxygen sensors out just to try and replace them, but I can't get to it. I mean, I have the slotted sockets and everything else, but just trying to crawl underneath the car up on jacks or high stands and trying to do this, it's not a very safe thing because you really got to use a lot of force, and I really don't want the car falling on me, so that's probably a job best left to a garage. Back to my custom data set. But obviously the car has problems.